We began this program by discussing the principles of what a steam turbine does, how it converts the energy from hot, high-pressure steam to a mechanical force that can be used to drive other pieces of rotary equipment that perform work. Understanding these basic principles is one of the first steps in learning how to operate a steam turbine. In addition, as an operator, you need to be able to identify the essential parts of the turbine you're working with and understand what each of these parts is designed to do during the various phases of turbine operation. For safe and efficient operation, every part of the turbine must be functioning properly. In this segment, we'll take a look at the basic components of a turbine and discuss what each of these components is supposed to do. A major external part of the steam turbine itself is the casing. This one's been cut away so we can see many of the components it contains. This part of the casing is where the steam enters the turbine. It's called the steam chest. Inside the steam chest is the governor valve. The governor valve is used to regulate the amount of steam that is admitted into the turbine. It controls steam flow to the nozzles and is an important part of the overall turbine control system, which we'll talk about later. The steam that has entered the steam chest through the governor valve moves on to the nozzles. As we discussed earlier, nozzles are the components that increase the velocity of the steam. The high-velocity steam from the nozzles is directed onto the first set of moving blades. This causes the blades and the shaft they're mounted on to turn. Then the steam flows through the fixed blades. These blades redirect the steam flow onto the next set of moving blades. This allows more energy to be extracted, so the moving blades and shaft continue to turn. From the second set of moving blades, the steam enters this chamber and is routed on out of the turbine. The shaft and the moving blades are commonly referred to as the rotor. The movement of the rotor is what produces the mechanical energy that can be used to drive other equipment. Bearings are used to help keep the rotor correctly positioned. This turbine uses a thrust bearing and two radial bearings. The thrust bearing prevents movement of the shaft lengthwise along the axis of the shaft. The radial bearings prevent movement of the shaft in a radial direction, or from side to side and up and down. The bearings minimize friction between the shaft and the casing of the turbine as well. Other basic turbine components are located outside of the casing. These external components are most important after the rotor is begun to turn and the turbine is being put into operation. They provide essential support so the turbine can function safely throughout the different phases of operation. In order to put the rotor's mechanical energy to work, the turbine's power must be transmitted to a piece of rotary equipment. A coupling is used to connect the turbine to the driven equipment. For safe operation when the turbine and its driven equipment are running, the coupling should be covered. The coupling cover, or guard, prevents personnel from getting their clothes or fingers caught in the rotating parts. During operation, the turbine must be stabilized so the rotor doesn't move out of its properly aligned position. Bearings, as we've already discussed, help position the rotor. In addition, a pedestal supports the turbine. Mounting the casing on a concrete foundation provides stability, too. Okay, we've looked at a turbine's basic components, including such parts as the casing, governor valve, nozzles, rotor, and fixed blading. In addition to these essential components that you're likely to find in almost any turbine, there are also some typical auxiliary or support devices and systems you need to know about. We'll look at them next.